This is Mr. Ashton going through the PPE paper from March 2017. Just to go through a couple of things, this was a non-calculated paper. You will require a compass and a ruler and stuff like that for this paper. Second page here, don't forget about all these formulae. This could be useful at some point. And then look at the first page, it says blank page. Do not write on this page. Right, question 1. Now, my class certainly, and probably a few other classes, had not been taught this before the PPE. If you still haven't been taught this, then by all means skip this question and we'll watch it another time, okay? Now this is a question on something called loci, which I know I'm planning on teaching the first week back after Easter. So it's called loci, so if you want to do any research on it, that's what it's called. It says the scale diagram opposite shows an isosceles camping field. The camping field is 10 metres long by 80 metres, 100 metres long by 80 metres wide. The river runs along AB, there's a hedge along AD, there's a fence along BC, DC is the opening to the access to the isosceles camping field. Now all of that stuff is already put onto the diagram there, okay, so although it's a lot of information there, don't really need it because they've gone and told us there, okay. They tell us that the scale 1 centimetre represents 10 metres in real life. The barbecue area is to be built on the camping field. The barbecue area must be nearer to the river than to the opening of the Eisteddfod camping field. So I'm going to work through these in bullet points. So I'm going to deal with this one first. Now, if we look where the river is, here's the river. And if we look where the Eisteddfod camping field is, it's there. Now, we need it to be nearer to this side. So what we need to do is cut this in half. The way that we cut in half using a compass, we open to obviously more than halfway. So obviously more than halfway. That looks obviously more than halfway to me, okay? Now, to do this, you could do it anywhere along this line here, but you'll have to line up the points, so it's safer to do it on a line. So what I do is I open my compass to obviously more than halfway, I draw a semicircle like that, and then I'm going to move the paper around here and point on the other side of where it is. So like once was on the river, once was on the Eisteddfod camping field. Make sure you line up that point so it's directly opposite there. I draw another arc. Okay, now that is called a line bisector, and what that does is it will cut things exactly in half. So when I line up these two intersections here and here, I draw a straight line through there, okay? Now make sure you do not cross out any of these workings or rub them out because they're all worth marks, okay? So I've dealt with the first bullet point. The next one says, nearer to the river than to the hedge. So here's the hedge, here's the river. Now that is making an angle, so we need to make an angle bisector. To make an angle bisector, you open your compass to roughly around about 3 centimetres, something that's going to feel comfortable when you're doing it. Now, the river and the hedge meet at this angle, angle A. So I'm going to put the point of the compass on A, and I'm going to draw an arc that crosses both of those lines. Now, this is entirely up to you, but I like to go and colour in where they cross the lines there and there. You then move your compass, leaving it exactly the same distance, put it on one of the points, draw an arc, move it to the other point, draw another arc like that, okay? And then what I do is I colour that one in, and I'll line it up with the angle, and line it up there, okay? Now, it's starting to look a bit messy because I've got all these lines on here, but they're supposed to be this. We've got to try and pretend that we can't see the pencil ones, and I start making a few decisions here as well. So it says nearer to the river than to the Eisteddfod camping field. So nearer to it means coming down this way. And then it says nearer to the river than to the hedge. So it's got to be this side of this line. Okay? Everywhere on this line is exactly the same distance from the hedge to the river. The final one says more than 30 metres from the corner of the field where the hedge meets the river. So that's the same corner we just did, this one. Okay? Now, I know that 1 centimetre represents 10 metres, so 30 metres must be 3 centimetres, because that's been times by 3, I times that by 3. So, ruler, pencil on 0, and yeah, there we go. Make sure you are accurate though. If it's not dead on 3, you'll lose a mark. You'll be allowed like 1 plus or minus, like so you're allowed 2.9 or 3.1, so make sure you're accurate. Now technically I draw a full circle around here, but really obviously anything outside the circle was needless, so I could have just drawn it just in the field there. And it says it has to be more than 30 metres from that corner, so it's got to be that side of the line. So all the things that do that are this bit here. You can see that I'm not an art teacher. Mr. Wicks wouldn't be very impressed with this, would he? But as long as you make it clear where your diagram is, fine, don't rub any of this out. Okay? Okay, next question was this one here. So it says, Lottie and Raphael decide to enter a prize draw. They agree to share any money in the ratio 3-2, respectively. So that means Lottie's 2, Raphael's 3. After winning a total of £2,000, they think again and decide that Lottie's share should be increased by 30%. Raphael thinks that his share will be reduced by 30%. Without calculations, explain why Raphael's thinking is incorrect. Okay, now the best way to describe this, I saw a few of you write this, was it was not an equal amount to begin with. I.e. Lottie had the smaller share, so that she's getting 30%, but of a smaller share, he's got a bigger share, he's got 1.5 times as much, so it's not the same amount, okay? Calculate the amount of money that Lottie wins after this decision is made to increase her share. So what we need to do, first of all, is add together the parts of the ratio. So we're going to do 2 plus 3 is 5. We will then do the total amount of money, which is 2,000. We will divide that by 5. Quick way to do this in your head. What's 2 divided by 5? Don't know. What's 20 divided by 5? 4. How many zeros appear? 2. So that answer would be 400, but there's lots of different ways to do that. That's for one part. And Lottie has 2 parts. So 2 times by 400 would equal £800, which is Lottie's original share. Now, I'm only explaining this to you. You wouldn't need to write all this because it's not a QWC question. Then what happens after this? So after winning the £2,000, they decide again, they agree that her share should be increased by 30%. So we need to find 10% of that, which would be 80. So then 30% would be 240. So we need to increase her share. That means we're going to add on 240 there. We're going to get 10,040 for Lottie's share. Okay. Part B says find the ratio used to share the money between Lottie and Raphael. Express your answer in simplest form. Now, Lottie gets this much. So Lottie, I'm going to put L.R. So she gets 10,040 and they won £2,000. So I need to work out how much Raphael's going to have. So take away 1,040. We'll take away 1,000 as 1,000, then take away 40 would be 960 quid. And we then need to express the answer in its simplest form. Make sure you're answering the question. So take a 0 off both sides, i.e. divide by 10. I'm going to halve each of those, so what's that? 52 and 48. I'm going to halve again to 26. That's a lie. 26 and 24, and again to 13 and 12, okay? Now it says Lottie to Raphael, so that's why luckily I've written that up there to help me. Lottie to Raphael, so it had to be 13 to 12, not 12 to 13, because it's got to be in that order there, okay? And Lottie was that money from before, okay? In another prize draw, it was planned to give £5,000 to the first prize. To make it more popular, the organisers decided to increase its prize by 26%. The most efficient way of doing this is calculating this amount is to do this calculation here. Now, I've taught my class that we do that by doing 100 plus or minus the percent in question, and we divide that by 100. And that's what they've done. They've added on 26 to get 126, and then divide it by 100 to get 1.26. We add when it's an increase, we subtract when it's a decrease. It says here the second prize is now decreased its prize by 6%. So we need to do 100, take away 6, and then divide that by 100. So that would be, what, 94 over 100, which would be 0.94 times by 3,000. Okay, you can't do it because it just says write down the calculation. I can't do that without a calculator. Okay? Okay. Upper and lower bounds. So, Luke has measured the length of the wall, which is 600 centimetres, correct to the nearest 10 centimetres. The bookcase, which is 147 centimetres, correct, the nearest 1 centimetre, and the nearest wardrobe, which is 250 centimetres, correct, the nearest centimetre. What is the greatest possible length of the wall? So whatever the nearest is, looking at anything that says nearest, all of those, we divide that by 2. So we're going to get 5 centimetres for the wall, we're going to get half a centimetre for the wardrobe, for the bookcase, and half a centimetre also for the wardrobe. Now, what we do to work out the lowest value is we take off 5 and we add on 5 to find the greatest possible value. So I need to add on 5, so I'm looking for 605, which is that one. Here, the least possible answer for the wardrobe, well, the wardrobe there, I'm going to take away 0.5, so I'm looking for 249.5, which is that one there. Okay, it says, can Luke be certain that his desk will fit in the space below? So what is his desk? Okay, so he's found a stylish computer desk made of laminate wood, and it is exactly 200 millimetres. Now, everything else is in centimetres, so it makes sense to change that to centimetres, and that was worth a mark, so make sure that you show that calculation, okay? So 200 centimetres, and I'm going to just put in brackets for consistent units. And then, what have we got after that? So then, we've got all this other stuff like measured to the nearest. So what we need to do is we need to work out the upper and lower bounds of both. Don't worry too much about anything else other than work out the upper and lower bounds and do it all, even if you don't think it's asking for it here, it's worth doing because you'll pick up loads of marks, okay? So I'm going to say, what do we have? We had the wall, and I'm going to say length, I'm going to say bound, and I'm going to say UB and LB. Okay, now the length of the wall was 600 centimetres. I found that to have a bound of 5 centimetres by measuring it to the nearest 10, and so I halved that. So its upper bound 605, so its lower bound is 595. If we do the bookcase, its length was 147. Its bound was just half a centimetre, so its upper bound would be 147.5. and its lower bound would be 146.5. And finally, the wardrobe. That is 250 centimetres, and its bound would be 0.5. So its upper bound would be 250.5 centimetres, and its lower bound would be 249.5 centimetres. Now you'll pick up a load of marks that table, and it really wasn't that much effort. Okay, it's probably worth about 2 marks that table, and that's worth 1 mark, so we're into 3 marks already. So what's the question asked me? Now I'll read it, now I've done that. Can Luke be certain that his desk will fit into the space available? So to be certain, we're going to think really, really like pessimists, okay? So to be pessimistic, we're going to say, right, let's make sure the wall is as low as possible. We're then going to say, let's make the bookcase and the wardrobe as big as possible, and then we've got to make sure that there's 200 centimetres left. And if that's not the case, then we'll have to make sure that we are getting a smaller desk so it will definitely fit in. Okay, so what I need to do is I need to add together those two lengths. So I'm going to get 250.5 plus 147.5. Line up your decimals. 5 add 5 is 10. 0 add 7 add 1 is 8. 9 and then 3. So that adds up to 398. Now what I could do here is I could say, well, if I'm going to add in this desk here, I could add that on there, or similarly, I could take that away from 595. I'm going to do that personally, but you could just say add that on and say it doesn't make the lower bound, so I can see that already because it's like 598. But here's another way to prove it as well. 595, 398, take away. Just don't forget, you haven't done this for a while, so you may well go wrong. 5 take away 8 is not 3, it's minus 3. We can't have minuses using this method. 15 take away 8 is 7. I'm going to have to borrow one from there as well. 18 take away 9 is 9, and then 4 take away 3 is 1. So I'm going to say Luke cannot be I can't spell Luke. Luke cannot be certain that the desk will fit, as there could be as little as 197 centimetres left. Now that is me being a total pessimist. It could be totally the other way around, then it would be fine. But this is me being like pessimistic. This would be me being optimistic if it was the other way around. Okay. Okay then. Next question. Number 4. 140 girls were asked how long they spent revising their GCSE examinations. The cumulative frequency diagram shows the results. Okay, so we're probably going to be doing some work on like interquartile range and stuff like that here. One second. Okay then, so first things first, what have we got? It says, estimate the median time that girls spent revising, circle your answer. Okay, so median time, come and find the highest value. It may not be the highest number there, so just check it goes up to as high as that. It does, so it's 140, so we go to 70. So we come across at 70, which is in between 60 and 80, which we'll say, I didn't mean to say that, I meant to say M for median. Come down and read off that value. Check the scale, it's going up in tens, and there's 10 little squares, so it's 52. 52 is my median. Calculate the number of girls who spent between 50 and 40 hours of revising. Okay, I'm going to try and use the pencil for this. 50 and 40 hours. Okay, so I'm going to come up from 40, there. I'm going to come up from 50, there. I'm going to come up and read off the frequency. So from 40, it's like that number there would be 50. And then from 50, it would be 60. So we're interested in how many people there are in this bit of the graph. So it's between 50 and 60, so we just find the difference of those two. So it'd be 10. So my answer there is 10. Okay then. The next question said, 25 girls spent between 30 and 50 hours revising. True or false? Between 30 and 50. Okay. Now I just found out that that's 10. So between 30 here, there, would be, that would be 30 there, wouldn't it? Come up and read off if I do it properly. The difference between 30 and 60 is 30. That's what they said. They said 25, that's false. It's actually 30. No girl spent more than 80 hours revising. That's true. It only goes up to 70. No, see? It only goes up to 70, so no one spent more than that. The modal group is 50 to 60. Now the modal means the most, so if you look between 50 and 60, it's the biggest bit of the graph, isn't it? That's the biggest jump. That means the most people in that bit there. To a small amount, even smaller amount here. Bigger than before, smaller again, but that's a huge jump, so yeah, that's true. 20 girls spent more than 60 hours revising. Okay, so again, come and read off from 60 there. And make sure you're really accurate here. It's one above that sort of like mini bold line. And I need to go and work out that scale. So that is a jump of 20. There are 10 little squares there, so one little square is worth 2. So there's 120, it's come back in 2, so 118, 116, 114, 112. So 112 to 140. 112 to 140. What do we get? 8 to 0. I make that 28. What do they say? 20 girls spent more. 20 girls spent more than that. Well, it's false. It's 28. Okay. Next question. It says 140 boys were asked how long they spent revising for their GCSE examinations. The cumulative frequency diagram shows the results below. Okay, what we asked. Trevor makes 2 statements. The boys' interquartile range is greater than the girls' interquartile range. On average, boys spent more time revising. Okay, so when we're talking averages, we're talking medians. And interquartile ranges, I need to go and work out the pair of them. Okay, so I'm going to go back and do the girls' one first. So the girls' interquartile range, it's a different colour pen here, it's quite confusing looking at all these lines. Now, I went across at 70 for the median. If I halve that number, that will tell me what the lower quartile is, because it's a quartile is a quarter and median is a half. So it's 35, so I'm looking for 2.5 squares. You've got to be as accurate as possible here. 2.5. There, I make that 35. And then coming down there, reading off that value. Now, I would like to see you writing on your lines, so it's really well detailed, is lower quartile equals 32. It's not 35, that's the line that you go across, the number you go across at, the 35, okay? And to work at the upper quartile, just do 70 add 35, that's 105. And you go across there, so 1, 2, so 105 there. Again, be as accurate as possible. 105 there. So that's the upper quartile. Now I can sort of see where my line's hit is sort of hovering. I'm going to force it over to the next box just to make it easy to read off. You'll be allowed to do that in the exam. And I make that 59. Okay. So coming back to, let's look here. Coming back to what that guy's statement was, I need to go and show the girls' interquartile range. So I'm going to say girls' interquartile range would equal 59 take away 32, which I'm going to rewrite as that actually. So that's 7, 2, 27. Now that was up for debate. You didn't actually have to have dead on that, but it had to be reasonably close to that. Okay, it depends how accurate you were when you're measuring. You are allowed a little bit of human error, and I now need to find the boys one. 10. Just seems to have lost. There it is. Okay, so the boys one now, I need to go and find median interquartile range. So again, 140, yes, highest point. So then I'm looking for 70. Come across. Median equals 40. And then half of 70 is 35, so I'll go and mark 30. There's 30, so 35 must be bang in the middle. And it's sort of gone halfway in a square. I'm going to go to the nearest square, which is that one there for me. So LQ will be equal to 18 for me. Okay, and then 35 plus 70 is 105. So there's 102, 104, 105. And going along there, that's my UQ. And I make that, so that's 1, 2, see if you can see what I'm doing. 1, 2, 3, 4, 5, 6. So the UQ is 46. Okay, so then the boys' UQ, what's that now? Boys' interquartile range is going to be 46, take away 18, which is 8, 2. So I make the boys 28 and the girls 27. Now some of you actually had the same, and if you had the same, you could actually get 27. They're allowing a little bit of error there, rounding to get the same answer. So if you said, oh, so therefore they're the same, he's wrong, that's fine. Now he said the boys' interquartile range is greater than the girls' range. Well, that's true, so I have shown this to be true. I've shown this statement is correct. Okay, and then for statement 2. Statement 2, what did you say? On average, boys spent more time revising. So the boys spent 40 on average. That's what we're talking about, averages. Although you could use modal, that would be something else you could do. The girls spent 52, so that's a lie. This statement is wrong. Statement is wrong as the girls' average, or the girls' median, state what it is rather than saying average. There's 3 averages, mean, median, mode, so you could use modal there, equals 52, compared to the boys, which equals 40. Okay, and it was 3 marks for that one and only 1 mark for that one.